Hello, my name is Prasad. I have more than a decade experience ranging from business intelligence, big data, and backend development. We'll be covering an interesting topic called database sharding. And as part of this, we'll be touching upon the evolution of database optimization and database scalability. Let's quickly go through the agenda. So we'll understand what is database sharding, why we need it, what are the different types of sharding, and this should help you decide if your particular use case can benefit with sharding. Let's start with understanding sharding as a concept. So the word sharding dates back to Old English, which means to cut something into pieces. Now think of a clay pot. You drop it to the ground, it breaks into pieces. Now each of these fragments is what is known as shards. If we apply this example to our data set, then our data set is the clay pot. And if we break down our data set into small chunks of homogeneous, manageable, delimited data, such that one chunk of data is independent of another chunk, then these individual chunks are what are known as shards. So this should help us understand what is database sharding. Now there are different types of data stores: relational, NoSQL, full text search, many more. But for the course of this video, let us consider relational database. Now, talking about the evolution and understanding how we got to sharding, let us quickly go through the different techniques that have been employed over the years, but without diving deep into each of these. Now, let's start with normalization. It has to do with data redundancy. Now, think of a table which has redundant data. So we break it down into multiple tables such that the redundancy of the data is taken care of, and these tables can refer to each other using foreign key references. Talking about indexing, the core concept behind indexing is to add certain metadata to tables which holds the information about individual records. This boosts with boosting the performance of reads. Caching. So caching is adding a layer of data which is stored in memory. We can use something like Redis. And most of the times caching is used when we know that certain requests, certain queries are frequent, and storing the result for these requests in memory helps boosting the performance. Next on the list, we have replication. So replication is deploying clones of the main database instance. Now these replication nodes can be used to offload the heavy read request coming into our system. Horizontal partitioning. Okay, we can think of horizontally slicing a table such that the first 10 records forms partition A, the next 10 records forms partition B, and so on. Now, because these partitions can be used as a filter, it helps with performant reads and also helps with performant writes. Now, talking about vertical partitioning, so this has to do with the varying frequency for accessing different data. So this can be addressed by some kind of functional implementation. We can even have a microservice architecture approach here, in which case these two distinct data sets can exist in their own domains. But after all these different techniques have been exhausted and we still are not meeting our SLA, then one can think about scaling this horizontally. And that is where one can consider sharding. So now let's understand why to shard database. So one is what we just covered is data is huge. Data has grown to a limit where all the standard techniques are proving ineffective. So scalability is one reason for sharding a database. Then performance optimization. Now, because sharding relies on partitioning, so this indirectly helps with performance optimization. Exhausted vertical scaling. So we reach a point where we have upgraded our instances, but beyond which there is no configuration that could help us. So we have to fall back on horizontal scaling approach. Another reason for opting for horizontal scaling is it could be cost effective compared to vertical scaling. Now, a good outcome of sharding when clubbed with replication is resilient systems. This should also help achieve your uptime SLAs and keep the outages to the minimum. Now let us understand partitioning and sharding, whether they are one and the same or whether they are different. So partitioning pivots data around a chosen key and groups data into homogeneous units. Sharding is partitioning but spread across multiple database instances. So what that means is to implement sharding, we first need to implement partitioning. But to implement partitioning, we do not need sharding. Partitioning is more performance driven. So sometimes partitioning can be used just to have performant operations in the database. Whereas sharding is purely driven by scalability. Let us understand different types of sharding. So one is application level, also known as functional, and another is database level sharding. So in case of application level sharding, the application holds the routing logic. Joins across shards, which should be avoided, but if we need them, they are to be handled at the application level. And so the business logic here is evolved, little complex. Now, multiple databases act as shards and are unaware of other shards. Whereas in case of database level sharding, the database abstracts routing to a particular partition. That also means that the complexity of routing is abstracted away from the developer. Now the joins across shards are a little better performant, but again, they should be avoided because then that defeats the purpose of having partitions. In this case, because database is managing the partitions, the database is aware of the underlying partitions. Talking about pros and cons, we have already touched upon the pros, which is performance optimization, scalability, having resilient systems. Again, because this is horizontal scaling, then it is also cost effective compared to vertical scaling. Talking about cons. So in scenarios where data is skewed and we need to employ resharding, then that adds an extra layer of complexity. Again, computations across shards are costly and are to be avoided as far as possible. Now, pivoting shard key for evolving needs is difficult. So let's say tomorrow there is a drastic change in the data set. Then to accommodate that, the changes required, although not impossible, are difficult to achieve. Now, what are the candidates for sharding? So, and before diving into that, let's understand that sharding should be the last resort when all other options are exhausted. So being said that, when is it a good idea? So again, exhausted vertical scaling. We have already exhausted different techniques like normalization, caching, replication, or if we expect substantial growth in the near future. Again, if the data delimitation is in place with established data pivot, such that individual partitions can exist independently and cross partition joins or calculations are ideally none. Again, if partitioned data into shards would help boosting the performance of the system, then in these scenarios, sharding is a good idea. When is it not a good idea? So, greenfield projects. So, one should never consider sharding from day one when starting a new project. If your data and schema is evolving, like your project is still not matured, or if you expect drastic data changes, then again, sharding is not the right choice. If sharding might result into skewed data, where sharding strategy cannot be established. So the future requirements are still not clear, or the or we still expect drastic changes, then again, as already said, it's better not to opt for sharding. So each scenario is different. What works for one scenario may not always work for other, and vice versa. So it's always best to put in due diligence while opting for sharding, because undoing changes made for sharding are difficult. It's like steering a huge ship. So it's better to be cautious. So that brings to the end of this video. I hope this video was informative and should help you with your decision if sharding can benefit your use case. Right? So again, that's it. And thank you for watching.